Welcome to the Explainer. Today we are tackling a puzzle, a 2,500-year-old puzzle that basically says you can't walk across a room. Seriously, it sounds crazy, but it questions the very nature of motion itself.
All right, let's just dive right in with a little thought experiment you can do right now. Picture yourself standing on one side of a room. You want to walk to the other side. Easy, right? Well, an ancient Greek philosopher named Zeno would tell you you can never actually get there. Let me show you what he meant.
So to get all the way across the room, you first have to get halfway there. I mean, that makes sense, right? You can't cross the whole distance without first covering half the distance.
Okay, so you're at the halfway point. Great. But to finish the rest of the journey, you have to cross what's left. And before you can do that, you have to cross half of that remaining distance. So now you've gone half plus another quarter, you're 3/4 of the way there.
But hold on, there's still a little bit left to go. And guess what? Before you can cross that last bit, you've got to cross half of it. You starting to see where this is going?
Yeah, this process of chopping the remaining distance in half, you can just keep doing it forever. No matter how close you get, there's always a tiny sliver of space left, and you always have to cross half of it first.
And that is the absolute core of the paradox. Zeno's point was that any single journey is actually made up of an infinite number of smaller journeys. So the big question is, how can you possibly complete an infinite number of tasks in a finite amount of time? It just sounds, well, impossible.
So this little puzzle, it's called Zeno's dichotomy paradox. And let me tell you, it completely baffled the brilliant thinkers of ancient Greece. I mean, they knew people could walk across rooms. They did it every day. But they couldn't poke a hole in the logic. The solution? It wouldn't show up for another 2,000 years, and it needed a whole new kind of math to solve it.
All right, so how do we solve this ancient headache? Well, the whole thing hinges on one single, really powerful idea from math. The idea that you can add up an infinite number of things and still end up with a normal, finite number. The technical term for this is a convergent series. Think of it as an endless list of numbers that when you add them all together, they don't just get bigger and bigger forever. Instead, they zero in on or converge to a single final total, and this is the key that's going to unlock Zeno's paradox.
Okay, let's connect this back to walking across the room. Let's just say the total distance is one whole room. The first part of your journey is half the room. The next part is a quarter, then an eighth, then a 16th, and on and on and on. This is the exact infinite series we're talking about. So after that first leg, you've covered half the distance, 0.5. Easy. All right, now add the next piece, that quarter of the room. So a half plus a quarter, that gets you to 0.75. You're now 3/4 of the way there. In the next chunk, the eighth, add that on, and you're at 0.875, or 7/8 of the total distance. See? With every single step, you're getting closer and closer.
Now this is what's so cool. Look at the pattern. Every time you add another piece of the journey, the total gets closer to 1, right? To that finish line across the room. But, and this is super important, it never, ever goes past 1. It just creeps closer and closer infinitely.
So the formal math here involves what's called a geometric series. The key is that each piece you add gets smaller and smaller, so small it practically disappears. It gets closer and closer to 0. And so, when you look at what happens when you have an infinite number of these steps, the total sum, it gets closer and closer to exactly 1.
And here's the really mind-bending part. In the world of calculus, the sum of all those infinite pieces isn't just approaching 1 or almost 1. It equals 1. Exactly. Think about that. You can add up an infinite number of chunks of distance, and they add up to a perfectly normal, finite number.
Okay, so now that we have this mathematical key, this whole idea of a convergent series, let's go back and use it to finally unlock Zeno's ancient puzzle.
You see, the whole paradox was built on an assumption that feels right, it feels intuitive, but it's just wrong. Zeno assumed that if you have an infinite number of tasks, it must take an infinite amount of time or distance. But as we just proved with the math, that's just not always the case.
Yeah, the real error is in this hidden assumption that infinitely many automatically means infinitely much. Just because you have an infinite number of steps to take doesn't mean the total distance you travel is also infinite. They're two different things.
And what's really cool is this works for time, too. Let's say it takes you 1 second to cross the first half of the room. Then it'll take you half a second to cross the next quarter, a quarter of a second for the next eighth, and so on. The chunks of time also form a convergent series. You end up completing an infinite number of things, sure, but each one takes less and less time, so you finish in a finite, totally normal amount of time.
Now, there is a really important catch here. You can't just assume that every infinite list of numbers adds up to something finite. Not all infinities are this well-behaved. For a series to converge, like the one in our room example, the numbers you're adding have to get small really, really fast. But take a look at this other one, the harmonic series. You're adding 1, then a half, then a third, then a fourth. The pieces are getting smaller, sure, but they're not shrinking fast enough. And believe it or not, if you keep adding those up forever, the total just keeps growing, all the way to infinity. It diverges. So, what's the big takeaway here? In a funny way, Zeno was kinda right. You can break a journey down into an infinite number of smaller parts. Where he went wrong was assuming that this must require infinite time. What this really shows us is that math gives us the tools, the language, to deal with these mind-bending concepts like infinity, in a way that our common sense, well, it just can't.
And that really leaves us with a final, pretty big question, doesn't it? If our own intuition, our gut feeling, can be so completely wrong about something as basic as walking from one side of a room to the other, what other obvious truths that we believe every day might also just be a trick of our intuition?